Hello everyone, welcome to my channel. This channel is focused on educational upliftment by teaching out the public of different important theories of everything and other all-encompassing theories, cosmologies, paradigm shifters, just things that you wouldn't generally hear about, things that have been suppressed and neglected because of their threat to the powers that be in whatever field. And these are usually things that could benefit your life if you knew about them, if you only knew. So today is our 395th video on Dewey B. Larson and the Reciprocal System of Theory, which is a theory of everything, or a system of theory, meaning that if you understand how the system works, you can plug in the system to any subject and get valuable answers. Mr. Larson was an engineer who lived in the 20th century out west, Portland area, and he died back in 1990, but not before. He put out many books and a lot of articles, talks. There was a journal dedicated to his research and those of his followers, and there's a lot of stuff out there, but very few people know about it. A lot of it is somewhat self-inflicted. Larson was a good writer, but not such a great teacher. If you read his books, the information is there, but sometimes it's a little bit hard to extract it, particularly if you're a layperson, you know, if you're not a scientist. Larson, I think, erroneously tried to speak to scientists with his new approach, and he probably would have been better off trying to speak with lay people instead, because scientists are going to be the last people in the room who get it, because they are more invested in the status quo, and they don't want to hear that they were making mistakes you know, back then, or they don't want to hear that they learned that the models that they learned are now debunked. You know, they want to remain relevant and they want to remain in control. But had Larson attempted to speak with more lay audiences, I think he would, and especially young audiences, I think he might have had more success. So we're going to try to approach it that way, by trying to boil it down for people maybe who don't have the scientific background, such as I don't have the scientific background, but you know, I can persevere and kind of figure out, you know, what they're talking about. And in fact, I was, in my personal experience, I pored over Larson's works for a long time, and then eventually I got my hands on like a college physics textbook, a college chemistry textbook, and I think it was a high school astronomy textbook, and I was able to like read through those things very quickly and understand what was going on because I had read Larson. Not, you know, because I have an affinity for those subjects, but because I had read Larson, I was able to understand the concepts in there. So, you know, and I was able to like kind of read right through the book, meaning that I could see when they were BSing me. I could see when they were overstating their case, where they were trying to cover something up. I could see when they were trying to make you think that they really knew what they were talking about when they actually really didn't. So Larson kind of really actually prepared me to study those subjects. So I think that the great audience for Larson's theory is an intelligent 13-year-old who's never taken any science classes yet. Now, Larson doesn't specifically write only about science. He has a couple books on economics, which he considers a scientific topic. He's also got a book on metaphysics, and which includes philosophy and religion and psychology, biology, and he says that his system of theory can be applied to any subject, but most of his work is on scientific topics. Now, the basic idea behind Larson's reciprocal system is that we live not in a universe of matter or a universe of energy, but in a universe of motion. And in Larson's world, motion is the relationship between space and time. And Larson is really referring to what he calls a scalar motion, not motion maybe the way that you would normally think of it, like a vectorial motion. The car is moving 10 miles an hour southeast. Scalar motion is a motion that has a magnitude but has no specific direction. So this is kind of a more generalized, non-localized, non-directional motion, which you can envision using a balloon with dots on it. If you take the balloon with dots on it and you blow up the balloon, all of the dots are going to be moving away from each other. That is a motion that doesn't have a specific direction. Every dot is moving away from every other dot. And in fact, the locations between the dots are also moving away from each other. And the motion doesn't acquire a direction until you arbitrarily assign one of the dots as a reference point, as the one that is motionless. Then you can start to see more of a directional motion. So the motion is really related to the reference point, not to the motion itself. The other parts about this is that, it sets up a reciprocal relationship between space and time. Space and time are reciprocals of one another. Motion is basically a relationship. Motion is basically a fraction, with space or time as the numerator and time or space as the denominator. Time and space can both come in multiple dimensions. Time and space are identical to each other, except that they are reciprocals. They have the same general qualities, except in kind of in reverse order. They don't exist in and of themselves. They only exist together in motion. If you have one unit of space in one unit of time, you have to have a full unit before you have either of those things. Larson defines the units. The unit of space is about 4.56 times 10 to the minus 8 meters, and the unit of time is 1.52 times 10 to the minus 16 seconds. And if you have one unit of space in one unit of time, you have what Larson calls unit speed, which is also known as the speed of light. So in Larson's system, the speed of light is the minimum. I would say the speed of light is the midpoint of the universe. In the legacy science system, the speed of light is the maximum speed of the universe. In Larson's system, it is the midpoint, meaning that half of the universe is actually moving faster than the speed of light, which Larson refers to as the cosmic sector. And then half the universe is moving slower, which is the half that we're familiar with. It's called the material sector. Here you have relationships based on 3 dimensions of stationary space and always progressing time. Time is always getting later and later and later. But in the cosmic sector, once you cross that speed of light boundary, you have 3 dimensions of stationary time. And you have clock space. Space is always getting farther and farther and farther apart, like on the surface of an expanding balloon. And so this speed of light is an important boundary in the reciprocal system. And it's basically the background motion, or the origin, the ether, the 0 point, the null point, the neutral point. In the legacy science system, that point is 0 motion. But in Larson's system, that point is motion outward at the speed of light in all directions. Larson refers to that as the progression of the natural reference system. Okay, so today is going to be our third, I believe, this is our 4th installment of the on the article here that we're reading, called "The Fundamentals of Science in the 21st Century." And this is a paper that Larson gave back in 1978. So he was kind of looking into the future, into our present. And he's talking about, first he talked about kind of the history of science background, you know, how the Greeks, first we started with the Sumerians and then got to the Greeks, and then we went into the Middle Ages and the scientific revolution, and then the, you know, the revolution of the early 20th century with Einstein and the quantum mechanists, and kind of pointed out the general evolution, and then showed how his theory would fit in here. And he ended this 3rd installment. So if you want to watch those, you just go back and watch the videos from the last 3 days. So I'll just go back about half a paragraph here. Our problem now is to bring this development to the attention of the scientific community. His development, his theory, the reciprocal system. Here we encounter the same obstacles that always faces innovators. Those who take a superficial look at the new development see only the fact that it challenges some popular ideas. They hold up their hands in horror and say, "These people disagree with Einstein. They must be crazy." I have yet to find any law of science that prohibits disagreeing with Einstein. But be that as it may, since this is such a common reaction, let us look at the situation and just see where this disagreement lies. Einstein changed the course of science by developing his 2 theories of relativity. First, the special theory, published in 1905, which applies only to uniform translational motion, and more than a decade later, the general theory, which applies to accelerated motion. Peter Bergman makes this comment about the relationship between the two. Quote, "It is quite true that the general theory of relativity is not consistent with the special theory any more than the special theory is with Newtonian mechanics. Each of these theories discards, in a sense, the conceptual framework of its predecessor. So it is impossible to agree fully with both the general theory and the special theory. Actually, few front-rank scientists have much confidence in the general theory, in spite of the lip service that is paid to it by the scientific community at large. Bryce DeWitt, one of the leading investigators in the gravitational field, which the general theory is supposed to cover, said categorically, quote, "As a fundamental physical theory, general relativity is a failure." P.W. Bridgman predicted that, quote, "arguments which have led up to the theory and the whole state of mind of most physicists with regard to it may someday become one of the puzzles of history. End quote. Thus, while we must concede that we disagree with the general theory on many counts, this is not much out of line with the most advanced scientific opinion. Whether or not, this is a quote from Paul Feyerabend, whether or not we disagree with the special theory, on the other hand, depends on just how this theory is defined. Bridgman, I'm sorry, this is not a quote, this is Larson. Bridgman comments that there is a tendency, quote, to define the content of the special theory of relativity as coextensive with the content of the Lorentz equations. Paul Feyerabend, a preeminent philosopher of science, puts it in this manner, quote, "It must be admitted, however, that Einstein's original interpretation of the special theory of relativity is hardly ever used by contemporary physics. For them, the theory of relativity consists of two elements. One, the Lorentz transformations, and two, mass-energy equivalence." Okay, just to backtrack just a second. So the Lorentz transformation is basically the kind of the time dilation, which led to the the clock paradox or whatever, the twin paradox, where if you go out in space and you fly around at the speed of light or near the speed of light, the time slows down. And Lorentz has an equation for that, Einstein employed that equation in his theory, special theory. And then the mass energy equivalence is just the E equals mc squared. Energy equals mass times the speed of light squared. Again, this speed of light constant, Larson is saying that that speed of light constant is the background motion of his universe. On this basis, we do not disagree with the special theory at all. We are in full agreement with both the Lorentz equations and the mass-energy equivalence. The conclusions that so many physicists have reached in accepting the mathematical relations and rejecting Einstein's interpretations are the same conclusions that I have previously noted as applying to all inventive theories. Such theories are all mathematically correct and all conceptually wrong. Thus, if anyone actually examines the situation instead of merely reacting emotionally, he will find that we disagree with Einstein's relativity theories only in the same way that general scientific opinion also disagrees with them. But we do not accept all of the unsubstantiated inferences that are currently being drawn from these theories, because our new development enables us to distinguish valid from invalid inferences. The existence of speeds greater than that of light is an outstanding example. Earlier, we examined the case of a particle accelerated to a very high speed by a presumably constant electrical force. Its acceleration decreases at a rate which will reduce it to zero at the speed of light. Since Newton's relation between force, mass, and acceleration, F equals ma, is merely a definition of force, the decrease in acceleration at high speeds must be due either to an increase in the mass or to a decrease in the force. There is no physical evidence to indicate which alternative is correct. Einstein simply assumed an increase in the mass. Our theoretical development now indicates that he made the wrong choice, and that the decrease in acceleration is actually due to a decrease in the effective force. At the time Einstein made his choice, there was nothing to indicate that it makes any real difference which of these alternatives is correct. Either one leads to some kind of a speed limitation. It is not likely, therefore, that Einstein gave the matter any extended consideration, but since our new development now indicates that speeds in excess of that of light definitely do exist, a review of the situation is obviously required. Again, that's the cosmic sector. Half the universe is moving faster than the speed of light in Larson's system. If Einstein's assumption of an increase in mass were correct, the limit at the speed of light would be absolute, as the mass would be infinite at that speed. But on the basis of our finding that what actually takes place is a decrease in the effective force, the limit is not on the speed, but on the capability of the process. All that the experiments actually show is that it is impossible to accelerate a physical object to a speed greater than that of light by electrical means, a conclusion that we also reach theoretically. But this does not preclude acceleration to higher speeds by other means, such as powerful explosions. By accepting Einstein's denial of the existence of speeds greater than the speed of light as gospel, that cannot be challenged. Modern science has closed the door on the answers to some of the most significant problems in the present day. It is this mistake that has caused astronomy to become more fantastic than science fiction, with its neutron stars, black holes, white holes, and all of the other extravagances. I have noted recently that quark stars have now joined this list. When the reciprocal system when the reciprocal relation between space and time is recognized, the need for all of this fictional science, as we may call it, is eliminated. The phenomena of the far-out astronomical regions can be explained on the same matter-of-fact basis that applies in our everyday world. Okay, that is the end of the paper. Now, I wish he would have gone on a little bit further to more specifically identify, what his theory actually does say. But the main point that he's bringing out is that his disagreement with relativity theory is not any different, really, than the mainstream science, and that really the only disagreement that he has is with this speed of light boundary, the speed of light limit that Einstein assumed was related only to all cases. And Larson's saying it's only related to cases with electrical means. And that if you have a powerful explosion, such as what you might have in a star or galaxy, that you can then accelerate past the speed of light. Okay. Tomorrow, I think we'll be digging into a different paper from Larson. What we're going to try to do is, Larson's got another maybe half dozen papers that I've selected that are, I think, telling or important or in some way. And I think we're going to look at those. Eventually, we're going to get into his the reading of his book, Basic Properties of Matter. which is basically his book on chemistry. And in that book, he more or less is able to predict from theory only, from his theory, his system of theory, he's able to predict the basic properties of matter, such as the melting point, or the specific heat, or the compressibility. And he compares his theoretical results coming directly from his head with the scientific tables, the empirical results that the scientists have built up over the centuries from laboratory research, from actually measuring the melting points of all the elements and compounds, or many of the compounds, and things like that. So we're going to take a look at that book. I don't know that we're going to read the whole thing, but we will get into at least a chunk of it. And then I'd also like to go over one of Larson's books on economics. Now, I don't know that we're going to read that one in its entirety either, but we're going to go over a big chunk of it. That one is called, got the attractive title of The Road to Permanent Prosperity. So if you're looking for permanent prosperity, check it out. We'll get into that book down the road this year, and then we'll be shifting over to some other topics. We've got some synergetic geometry from Buckminster Fuller. We got some quantum arithmetic from Ben Iverson. We're going to look into a little nutrition, and we're probably going to look into some ancient history, particularly religion, and there's several other, kind of smaller subjects that we're also going to get into this year. So once we've got a couple more months on Larson though, so we're going to stick with Larson. We might start branching out into other subjects at the same time. I've been toying with the idea of doing some kind of live presentation as well, where we can start working in some of that tree of life stuff that I covered not last year but the year before. And if you're interested in the ancient Egyptian tree of life, then go back and look at my videos. I'd like to take those videos of my 144 fractal faculties and kind of update them, and most of them are kind of like rough drafts, and I'd like to turn them into second drafts on the road to refining them even more. So it's going to be great. It's going to be a great year over time. But, tomorrow we're going to be delving into another paper from Mr. Larson. Thanks for tuning in today. Have a great day.